Okay. Day 2 review answers, part 2. Square root equations. I kind of talked about this with number 10 with the domain, but starting with your domain on this is the easiest because it tells you where to start your graph. What makes this go to 0 is 3. So right away before I even make my graph, I know my domain is bracket 3 to infinity. And then you have a calculator, so you can pick whatever you want. But I try to pick numbers that give me perfect squares. So I definitely put 3 in there to get 0. 0 minus 4 is negative 4. Think about the transformations of this graph. It's moving right 3 and down 4. The negative out front is flipping it over. So like that normal parent graph starts here and goes up, but this one is the other way. And then you can pick whatever you want, but I picked 4 because 4 minus 3 gives me 1. So then that's the negative square root of 1, which is 1, minus 4, which gave me negative 5. And then I also picked 7 because 7 minus 3 is 4. So I get negative square root of 4, or negative 2 minus 4, which is negative 6. And so you can see I kind of put my dots there. Know the shape. It's a half of a parabola on its side because a square root graph is the inverse of a quadratic graph, but we only do half of it. Otherwise, it wouldn't be a function. It wouldn't pass the vertical line test. So again, practice doing that. Number 12 is a piecewise function. We talked about piecewise functions, I don't know, beginning of chapter 2, chapter 1, I don't really remember. But remember that a piecewise function is just 3 different or multiple graphs together, in this case 3. And this part at the end is the most important because it tells you where to break your graphs up. And so I drew these dotted lines on my graph. You don't have to draw the dotted lines on the graph because they're not really part of the graph, but it helps me break it up. So the line y equals 4, like these are all equations. Y equals 4 is just a horizontal line. But why did I stop it here? Because this told me that it's bigger than, greater than or equal to negative 6, but less than, this was a scribble here, it wasn't a line, less than negative 1. So closed circle, open circle, horizontal line. In the middle is just x squared. Quadratic graph starts at 0, 0, over 1, up 1, over 1, up 3. Or make an xy chart. But why did I stop it where I stopped it? Because of these points here, right? So negative 1 is a closed circle, so I stopped it there. But on the other side, it went all the way to 2, but it was not included. So at 2, it goes up to 4, but that's an open circle. And then 2x minus 5, you could start at the y-intercept of negative 5 and go up 2 over 1, up 2 over 1 to get to this point. Or I just plugged 2 in, and I got 4 minus 5, which is negative 1. And then from there, I did my slope. Up 2 over 1, up 2 over 1, up 2 over 1. And it doesn't have a close point, so it's the only one that gets an arrow on there. Part B review, please try this. Make sure you can do it. It's going to be worth a good amount of points on the test. Number 13 had you put it in vertex form and graph it. So I did this both ways. I did completing the square to put it in vertex form, so that's where I did pen here, but it's kind of a mess. But half of 2, well, I factored the 3 out first, and then I completed the square. Half of negative 2 is negative 1 squared, which is 1. So if I add 1 on the inside, I subtract 1 on the outside, but I had to multiply that by 3. So I'm really taking minus 3 on the outside. So that's how I got negative 7, negative 4 minus 3, and then I did the completing the square. But remember, if you're like, I have no clue what you're talking about, remember that another way to find the vertex is to just do negative b over 2a. So that's what I did over here. Negative b would be positive 6. Over 2 times a would be 6. And I got 1. And that is the h of vertex form. And then how do I find the k? I plug it back in. So I did f of 1. I plugged it in. I got negative 7. And that would be your k. So remember that vertex form is a times x minus h squared plus k. And we like vertex form because when it's in vertex form, I can see that vertex right there of 1, negative 7. But you can totally find the vertex by not completing the square. So, maybe go back and look at your notes and kind of see which way you like to do it. And then I just graphed it. So my vertex was 1, negative 7. And then I used the 1, 3, 5 rule, but it's stretched by a factor of 3. So instead of going over 1, up 1, I went over 1, up 3, and then over 1, up 9, because I had to multiply 3 by 3. But you could also make an xy chart there, or you could use the fact that the y-intercept is negative 4 Again, go back, look at your notes to think about that. 14 has 3 parts to it. Adding, subtracting, multiplying, and dividing with functions. The domains of the original functions go with these functions. And if their domains are all real numbers, then the new domain is all real numbers. It's fantastic. But on number 14, when you subtract them, you have to take their original domains. And this one, what's the domain? It can't equal -2. This one, the domain can't equal -5. So the domain to adding, subtracting, or multiplying them is just adding that in. And so I did interval notation. I think your answer key gave you both. Like you could also say x can't equal -2, x can't equal 5 if you don't like all the interval stuff. And then we did this on part 1 already. Adding and subtracting fractions, you have to get a common denominator. So x plus 2 and x minus 5 have nothing in common. So that was my common denominator, and I had to multiply by what was missing. And you can kind of look at my work there and see how to do that if you didn't get there. With dividing, remember dividing fractions is the same as multiplying by the reciprocal, so that was my first step. I changed this to multiplying by x minus 5 over 4x. And then the only thing I could do on this was cross out the x's. Multiplying, you don't have to get a common denominator. You just multiply across the top, multiply across the bottom, simplify if you can. So this was my answer. Why is my domain different than the first one? Because when you're dividing, you have to include any new domain restrictions. And so we still can't have -2 and 5 from the original problems. But when we write it like this, we also can't have 0 because now we have 4x in our denominator, and 0 would be another excluded value. Okay? Okay. What about f of g? Remember, f of g is called composition and orders with inside function and put it in the outside function. So what I did is I took g, which is 4x over x minus 5, and then everywhere there's an x in f, and f was x over x plus 2. So everywhere there was an x, I have to replace it with g. So I end up with 4x over x minus 5 over 4x over x minus 5 plus 2. We did one problem like this when we were doing these. And it's just a lot of algebra. It's a lot of getting a common denominator. So you can kind of see my work here. What did I do first? I worked with just the denominator. So I left this alone, and I just got a common denominator between these two. So this is 2 over 1. So you can see I multiplied by x minus 5 on the top and the bottom. And then I just added across the top, like distribute. And then now this looks like what we just did on the previous one. Now I have a fraction divided by a fraction. So I'm going to multiply by the reciprocal. 4x plus 2x is 6x, so that's where this came from. It worked out really nice that the x minus 5's canceled. And so then I got this as my answer. But you can cancel out a 2 here, so that's why the answer in the answer key they gave you is this. Always look for simplifying. Okay, so that's a lot of work. The domain of a composition function, you have to take the domain of the new function. So right away, looking at this answer, I knew that x couldn't equal 5/3 because add 5 divided by 3. But you only take the inherited domain of the inside function. So it doesn't matter what f couldn't be. That doesn't count. It's just what's the inside function. So on this one, what couldn't this domain be? It couldn't be 5. And so that's my new domain. So you take the domain of the new function along with the inside function, whatever the restrictions on that domain is. Again, try the one on B and see if you can get that. Number 15 is a polynomial function, and I just kind of did all the stuff I remembered when we did this in chapter 2, I think. So right away, I looked at the zeros because it was already factored. So the zeros, I knew that this had a 0 at 0 and at 5 and at -3. Remember, the exponent tells you whether it touches or crosses the graph, and it tells you about the multiplicity. So a multiplicity of 3, because it's an exponent of 3, and that's odd, so it crosses. At x minus 5, it's no multiplicity, so it should just go like straight through the graph, but it's still odd, so it crosses. And -3 has an exponent of 2. That's a multiplicity of 2, which means it's just going to touch the x-axis and then turn and go back whatever way it happens to be. These numbers are not great. This is why on the answer key it says this is just a sketch, because they didn't label their y-axis. I didn't label my y-axis. Gosh, excuse me. I didn't label my y-axis until I made my xy chart. And so, what do I know? I knew it was a degree 6. How did I know that? Because I added up my exponents, 3, 4, 5, 6. It's a negative leading coefficient, so it's even, but it's negative, so I knew both arrows were going to point down. If you didn't know that, you would have to pick more points than I did. I only picked points in between my zeros, and so you can see here's my XY chart that I made. I plugged in -2. I plugged in -1, and I got -56 and -24. I plugged in 1, and I got 64. I plugged in 3, and I got 1944. And I plugged in 4, and I got over 3,000. You could do this a few ways. You could just make those points go way off your graph and come back down. I just decided to make my graph go by 1,000 so that I could fit my points on there. But notice that that means that even at 1, when it's at 64, because my graph is going by 1,000, it doesn't really look like it's very far up. The other option would be just to kind of focus on the x-axis and make your y still really small and go from there. Again, practice the one on part B. The other thing that this asked for is it asked where is it greater than 0 and where is f of x less than 0. F of x is y. So when it says where is f of x greater than 0, it just means where is the graph above the x-axis, right? Where are the y values above the x-axis? And once you look at your graph, you can just see it's above the x-axis between the 0 of 0 and 5. This is the only place. So that's why the answer is it's greater than 0 from 0 to 5. And then everywhere else on this graph, except for the zeros, it's below the x-axis. That means where are the y's negative? And so you can see I said from -∞ to -3, from -3 to 0, and from 5 to infinity. Those are just another way of talking about like where is it above the x-axis and below the x-axis. 16. You cannot do synthetic division on this because you can only do synthetic division if you're dividing by an x to the first power. So this is one that they kind of force you to do a long division on. You can see all my scribbles here. I should not have done this in pen, but I did. You can kind of see my mistakes that happened. One thing I would say, fill your zeros in. So even in this, it went from 2x squared straight to 6, so I put in a 0x, so my exponents would match. And then this went from x to the third to x, so I put a 0x squared. Maybe not a bad idea if you really forget this. Sorry, excuse me. To go back to your notes when we did long and synthetic division and look back at that video to remind yourself. But you have to say, like, what do I multiply this by to get this? And then you fill in the top numbers, one at a time. So I started with x squared here because x squared times 2x squared gives me 2x to the fourth. Like, it's always to match this. But I have to take this times all of this. So just by putting this x squared here, I fill in this whole line here, right? So I got 0x to the third, and 6 times x squared is 6x squared. But remember, in long division, you're subtracting, and that's where my mistakes always happen, which is where some scribbles happened here. I subtract, and then I bring down the next number, and I repeat myself. And so then I say, what do I multiply 2x squared by to get negative 8x squared would be negative 4x, because negative 4x times 2x squared is negative 8x to the third. And then I subtracted everything again, bring down the next number, do it again. So why did I get negative 3 here? Because I had negative 6x squared. What do I multiply this by to get this? It's negative 3. I do all this, and then when I have nothing left to bring down, this is my remainder, which I wrote it in fraction form. On the paper, they just asked for the quotient. The quotient's this, and they asked for the remainder, which is this. If you wrote it like the answer key did, that's right. If you want to write it in fraction form, I'm okay with that too. Okay, but definitely worth practicing. And again, if you get things mixed up, I'm looking for the process, and you can still get some partial credit. 17 asked you to find the zeros here. You totally could have done PRZs on this. But again, I noticed just like the one from yesterday that it's factorable. So I did factor by grouping where I factored these two and these two. I took the x plus 2 together. I put this here. And then these are my answers. The one on yesterday's part was an inequality, so we had more steps, but if it's factor by grouping, do factor by grouping. 18 is another one that you could factor first. And so on this one, you could factor out an x squared from the beginning. And then this is just a quadratic, and you could do the quadratic formula. Or again, I just factored, and I got 3 answers. It's a degree 4, but remember this one has a multiplicity of 2. So that's why we just got 3 answers. And then 19 asks for PRZs. It just asks you to list them. Thank goodness, because I wouldn't want to find them on this one. But remember that PRZs are factors of the constant. So 36 has a ton of factors. So that's all my factors of 36 divided by factors of the leading coefficient, which in this case is 4. And then you had to work out all the options. And so if you have questions on where I'm getting all of those, I just took everything over 1, everything over 2, and everything over 4. There's a lot of repeats, so I didn't repeat anything. But if you have questions on how I got those, please ask me. And then number 20, my scribbles here, because I tried to do this like the other ones. I tried to do factor by grouping, but you can't factor anything out of 35 and 12, and so it wasn't going to work. So if it doesn't work, to find your zeros, you have to do your PRZs. So I kind of wrote out my PRZs, and I just started guessing. I plug in 1, and I got negative 24. I plugged in negative 1, and I got 40. And I said, well, this doesn't seem like it's going very well. So I went ahead and skipped straight to the fractions. So then I did 1/3 next, and I just got lucky that I found it. But that's the part that can take some time, trying to find those zeros. But remember, once you find a zero, you do division. I do synthetic division. And if you get 0 here, you should get 0 here. And then you write what's left. And if this is a 3rd degree, what's left is a quadratic. And we know how to find a quadratic or solve a quadratic. You could solve it from here. You could do the quadratic formula. I divided by 3 first because everything was divisible by 3. And then I just factored it. But again, you could do the quadratic formula. Don't forget to bring down the answer that you found with synthetic division. And then that's the answer. All right? Again, keep working on part B. Your final is 1.